Okay, so well, let's jump into it. We've sort of circled around a little bit of
Right,
it. Let's
exactly.
talk about the Keyfactor report from December. So I want to open these numbers up a bit. You found that one in 100 every 172 certificates are vulnerable to attack due to poor random number generation. So first of all, let's talk about what one in every 172 certificates means numerically. How many certificates on average is this?
Yeah, well, that's a good. So there's a lot of certificates out there. I think just to
Yeah.
clarify a couple things, just for the audience. First off, I want to give credit to my colleague JD Kilgallen, who did
Okay.
most of the actual research within Keyfactor. What he did was to take a data set that we had created. So Keyfactor, our company focuses on making the use of cryptography easy for our customers, managing digital certificates and keys, making it easy to apply that cryptography, offering things as managed services and so forth to offload some of the expertise and the need for that expertise inside of organizations. As a part of that, our software is actually able to scan networks and gather up the digital certificates that are in use on those networks. So what we did was actually aim that at the internet at large. And we have
Okay.
a data set of every single certificate that has been exposed to the internet over about a 2.5 year span.
Hmm.
And that includes all the public websites that you could ever think of or name, as well as any other network devices that happen to be on the internet, webcams, routers, etc.
Wow.
In that data set, that's where that 1 in 172 came from. So if you were to look at public certificates, the certificates that are protecting Amazon.com or probably your website, those are vulnerable at a much smaller clip. So I believe of that set, we found maybe 5 out of the data set in total was about 82 million certificates, somewhere in that range.
Okay.
We broke about 500,000, which is a lot
Yeah.
to think about that.
Yeah.
But what was interesting and why that report is really kind of focused on the IoT piece is it kind of exposes the fact that some of these constrained devices that aren't a normal PC or a web server or so forth have trouble generating keys that are random enough, and that fact can be exploited in ways that can cause serious problems.
So, for listeners who don't really get the severity of this issue, what does this many insecure certificates mean in terms of available attack surface for hackers?
Yeah, I think for the devices in question, there were a few device types that were particularly vulnerable and seemed to have issues. The vendor has been contacted about that. I can't really relay any status as to how they've addressed that issue yet.
No.
But I think in terms of consumers and so forth, this to me really underscores one of the bigger problems with IoT in general is that designing cryptography and for these systems, in a lot of cases, you can't use some of the same procedures and software and libraries and so forth that you used in your Windows machine or in your Mac or other more beefy devices. A lot of those just aren't as capable of, there's constraints in these devices in lots of different ways. Sometimes they can't communicate as well. Sometimes they can't support some of the preferred newer cryptographic algorithms or key sizes. So you have to make compromises in those areas. It's also, I think, just a case of, as I mentioned at the beginning, it's easy to do crypto wrong and not realize it. And I think this is one of those cases where you have code that says generate a random key. It generates a key. It works. It communicates just fine. Turns out that key is not nearly as random as it should be, and is far more easy to guess than it should be. And that leads to problems when people who know what to look for start looking.